Okay, so when you're looking at limits, you're looking at something approaching a value, and you're doing like tiny little increments, getting closer and closer to that value. Okay. So limit. There's a couple things here. Your notation first. We can have the limit of f of x as x approaches a equals L. That's just limit notation and how you read it, okay? What this means, as x gets very close to a, the y value of f of x gets very close to L. Okay, I said it gets very close to L. Does it equal L?
No.
Could it?
Yes.
Yeah, it could, but it won't always, okay? It just gets really close to it. And guys, I actually think this spring example is more confusing than it is helpful. It does. So let's look at we're just going to do the second one here. So consider that you're entering the highway from an on-ramp. What speed are you approaching as you continue driving on the highway? I'm going to draw a graph and write a limit statement for this. So we're going to have time on our x-axis. We're going to have our speed on our y-axis up here. So if you're driving, you're getting on an on-ramp to get on the highway, what's happening with the speed of your car?
You're accelerating.
Right. And then, let's pretend there's no traffic, which I know never happens around here. So,
where are we?
We're in Nebraska.
Okay.
So no traffic, we're good.
I've been in Nebraska, there's actually a lot of traffic.
On I-80, there's a decent amount of traffic, but
I've never been in Nebraska.
okay. Sometimes there is. So you're going on the on-ramp, you're going to speed up, and then do you continue speeding up?
No, you
You're
stop
gonna, like,
once you get to the speed limit.
Right, so you're going to, let's say the speed limit's 65 miles an hour.
65.
She bought it.
Yeah. See, if we're in Nebraska, the speed limit's 75 on the highway. Let's take this 65 miles an hour. Totally not labeling my graph in the way that you should, but let's say, I don't know, speed. Let's say it takes you like 10 seconds to get there. So, what we could say here is the limit of our function as x approaches 10 equals what? Like, what are we leveling out to as we get to 10 seconds? Yes. Well, good. I'm glad we're getting it now. Yes. Well, hopefully this will be a good. In your class.
We did notes every day.
Yeah,
We learned it all.
All right, so let's practice a few limit problems. So we're going to just do these from graphs to begin with. Okay, you guys see it? Hopefully it's not too small on your paper there. Our copiers are not working well, so I was trying not to staple a packet for you. They're terrible, guys. It's awful. Okay, so the first one here, f of x is just our graph. So the limit of f of x as x approaches 1, and then do you guys see the little negative up there? Do you remember what that means?
From the left.
From the left. So we'll use magic pen here. So we are focusing in just on this, right? Ooh, that got ugly quickly. There we go. All right, we'll do the other one. We'll do the zoom in one. Right, like that's the only part of the graph we want to look at. Okay. So as nothing else. So as you come from the left and you get really close to 1, what y value are we at? 2. So, okay, here's 1 on the x-axis, right?
Oh,
So as you are approaching this guy, you're coming from the left. Like, think about it, you're a little person here and you are walking along the graph from the left. Okay? The y value you're approaching is 2, right? Okay? What if we start walking from the right? Also 2. Okay, do you guys remember? If the left and the right match, what does that mean about the overall limit? So it's the same. So that is 2. All right. Then f of 1. That means exactly what does y equal when x equals 1? 2. Okay, we got a lot of 2's going on here. So far, so good, right? All right, let's look at the second one. X approaches 1 from the left. So you're walking along the graph from the left. What are you approaching?
wow.
A lot of trash. All right, so 1 from the left, what are we approaching? I know there's a hole there. You're not going to fall into the hole. You're walking right up to the edge of the hole and looking down. What y value are you at? Right on the edge of the hole. You were at 2. Okay, then you walk from the other side. Also 2. Did they match? Yes. So what is the limit of our function as x approaches 1? Also 2. Okay, what about f of 1? Does not exist because it's a hole, right? So you can just say d and e. Okay? You guys try the next one. You're walking along. Is the dot throwing you guys off? Sorta. All right, let's go through it. So again, we're going to be walking. If I'm walking along this graph from the left, I'm walking and I'm looking down in the hole. Am I like jumping up here to this dot as I walk along? No, you are approaching the hole. So what y value are you approaching? 2. Okay. What about if you come from the right? Okay. Did they match? Yes, so the next one is 2. Okay, then the f of 1. What does y actually equal when x equals 1? 4. Yes. Okay. It's coming back, okay. Yep. Hopefully it's either coming back or you get it this year. All right, try the next one for me. This one's a little different. And your line kind of disappeared for one of them. It should have, yeah, it jumped over there. You had an extra line. Alright guys, let's look. Okay, from the left, so here we are walking along. What are we approaching? 2, okay. From the right. 4, okay. Did those 2 match? No. So what do I say for the next one? Does not exist, yes. Okay. And then what about f of 1? 4. Okay. Good. All right, let's keep going. All right, we're going to do the next one together. Okay, so this time x is approaching 2. It's not really drawn in there, but do you guys understand that there's an asymptote right there too? Does that make sense? Okay. So as we approach 2 from the left, so here I am walking, I would be walking forever up there. What is way up there? Infinity. Now, is infinity a defined value? No. So what else do I need to say with this infinity? Does not exist, actually. You need both of those pieces. The limit itself does not exist, but you can tell me the direction that the graph is heading. Okay? So what about from the right? What are you going to tell me? Yep. Infinity does not exist.
So like that little graph will be the same.
Yes, exactly. All right. Now, did they match? Were they going the same way? So what do you think you're going to tell me for just as x approaches 2? And does not exist. You're going to tell me the exact same thing. What if they didn't match? What do you think you'd tell me? Just does not exist, right? Okay. All right, what about f of 2? What? Does it equal infinity? Just does not exist. It's an asymptote, guys, okay? There is no graph happening when x equals 2. There's no y value that goes with it. It does not exist. Okay. All right, so you guys try them. We're going to talk about oscillating different today, so we don't do that one today. So just try the next one. What do you guys think for 2 from the left? Infinity does not exist. What about 2 from the right? Infinity does not exist. Good. So what about just the limit overall at 2? Good. And f of 2? It's a whole lot of does not exist, but yes, that is right. Okay. All right, we are skipping the next one. That's an oscillating function. We're just not talking about that today. So, yeah.
It does not exist in infinity.
I would take it, but that's okay. That's fine. You just need both parts. It's not like it's an ordered pair, you know, where this is X and this is Y. It's just you need both parts. Okay, so you guys are going to try this. Look at the graph here and try to answer all of those limit questions for me.
No, it's Mr. Thomas's.
Okay.
I just don't share mine. Mine is in my house somewhere.
Everything's really from school. Oh, my older brother, he probably took it from.
It's this house.
Yeah.
So it's a whole. Oh, yeah, I was, sorry, I was reading. Yes.
All right, guys, let's go through these. So as x approaches -2, what did you guys come up with? 3. What about 1 from the left? 1, good. 1 from the right? Good, just 1? Does not exist. And f of 1? -1, good. For which one? I'm sorry.
The second one.
1 from the left. So you're walking. you're approaching that little hole. You're not going to fall into it. What are you really close to the edge of the hole? Your y value is 1. So it doesn't matter that it's an open circle there. It's just what are you getting really, really, really close to. Okay. All right. What about as x approaches 4? What did you get?
This one is less.
And infinity, right? Don't both of them go? Okay, so it's infinity does not exist. All right, then the next two are a little different. As x approaches infinity, that is talking about the end behavior of your graph, as your graph goes forever that way. No, it looks like it's leveling out at a horizontal asymptote. 0, yes. What about as we approach negative infinity? What does it look like it's leveling out at? 1. You guys okay with those? All right. Then the limit as x approaches 7. What do you think? 1. Okay. We see why it's not 3? Okay, but then f of 7 would equal 3. Questions on any of those? Okay. I just want to talk about one other thing. Let's say our graph over on the left here, let's say it did something like that on the end. And I asked you the limit as x approaches negative infinity. Where is your graph going? Infinity. You don't say does not exist for this one. If this is an infinity, if what it's approaching is an infinity, you can have just infinity as c. Okay? If what it's approaching is a number, you can't have infinity as the answer. You have to also include the does not exist. Okay, you guys see the difference? Okay. Alright, I think flip your page over. All right, we are not going to go through every single one of these table problems because it's not that much fun to fill out the table, really. So let's do the first one together. It says to write the limit statement as part of your answer, so let's go ahead and set that up. We would say the limit of f of x as x approaches 1. I'm saying 1 because 1 is what's in the middle here that we're finding values left and right, okay? Go ahead and get out your calculator. Let me open up mine. Maybe. So go ahead and enter that x squared minus 1 over x minus 1 in your y equals. Still don't have one.
That's coming today. Coming to Amazon Monday shipping. Top box of
I say one day. I thought you ordered it last week. That is not one day shipping.
it. Tried already. Ordered it.
Where's yours?
What?
You're not going to actually be graphing anything just yet. When we're doing the table, you're not going to look at the graph. Later, we'll look at the graph. I'm just waiting for my calculator to open. It's not fast. All right, so I'm going to my y equals. Do you guys know where the shortcut key is for the fraction? Okay. Push alpha and then y equals, and you get this little shortcut menu, and the first one is the fraction. If you're using a calculator that you just borrowed from me, you will not have this on there, okay? It's not on the old one, so. So then it pops up just into the fraction, so you can easily, it's very nice. X squared, it was x squared minus 1 over x minus 1, okay. Okay, again, don't graph this. See all this error syntax stuff? All right, mine ended up working, but it may not show up on your graph if you have your stat plot on, if you have issues with your list, anything like that. We don't need the graph right now. We're going to look at the table. Before we go to table, we need to go to table set. So that is second window. All right, right now it's saying it's going to start at 3.14 and change by 0.1. That is not helpful at all for what I'm looking for. Remember, we're looking as x approaches 1 for our limit, right? So I want my table to start at 1. What it's changing by, we can certainly start with the 0.1. That is fine. So then you go second graph and you go to your table. Is everybody at this table with me? If you are not at this table, raise your hand so that I can help you. Okay, we'll wait for you. So I want to make sure everybody sees how this goes. I arrowed up 1. No? Anybody else? But again, you don't need to graph. All right, tables, troubles. So this calculator doesn't understand. If you want that Anybody else? We're all here now? Yes? Okay. So in your chart, you'll notice you did have x being 0.9, you have the x being 1, and you had x being 1.1. You have a lot of other x's too, but do you guys see those 3? These you should write down. You should write 1.9 for 0.9. You can write error or it does not exist, whatever you want for 1, and then 2.1 for that one. So this, was it 1.9 and 2.1?
Yes.
Okay, thank you. Okay, we are going to go back to our table set again. So, second window. Again, we want to start at 1, okay? Every time we're going to start at whatever that limit is approaching. But instead of going by 0.1, any thoughts as to what I might want to go by next? 0.01, yes. 0.01. And then you go back to your table. Yeah. Oh, yes. The notes. Do you guys see now 0.99, which is something we want? We have a y value for, and 1.01. Yes, okay, so put those on your chart. And then we can do it again. What do you think you should change the table set to? 0.001? Or are you guys noticing a pattern that's happening here? Yeah, I think you can probably guess. It goes 1.9, 1.99, maybe 1.999.
Yep.
2.1, 2.01, 2.001.
Yep.
Okay. So, we have enough information now to actually say what the limit is. So as our x values get close to 1, so as we squeeze in on both sides, what is happening to my y values? What are they getting really close to? 2. Okay, 2, right? 1.999, 2.001, aren't those really, really close to 2? Yes, so the limit is 2. Do we see it? Yeah? All right, so that is your answer for that. Okay there? We're gonna make it. All right, so letter B. Let's do this one partly because I want you to just practice being in the absolute value. There's a shortcut for that too if you have the updated calculator. So we're gonna go to our y equals. Clear that out of there. And then, sorry, I forgot what it was. Absolute value of x minus 1 over x minus 1. So we need a fraction. So alpha y equals. First one is your fraction. Okay. Then we need the absolute value. So if you do alpha window, you have another shortcut menu. And the first one there that is the abs, that's absolute value. And it was x minus 1. Over x minus 1. Okay, so I want you guys to try to finish your chart from here. Go to your table set, think about where you want to start, which is 1, and then what you want to change by so you can fill in your chart. should only say error for one. Like that should be an error, but none of the other ones should be.
You want X and Y must be the median. So, anytime I give you the option, like, we're going to, the distinction
All right, guys, let's fill in our chart here. So 0.9, what'd you get? Okay, 0.99, what'd you get? 0.999. Okay, what about 1.001? 1.01? 1.1? Okay. So, from the left and from the right, are they meeting? Do they match? No. So what are you going to tell me about the limit?
Does not exist.
Good. Okay, and remember this notation. Limit of f of x as x approaches 1 does not exist. That's the funny notation. Do we need more table ones, or are we good with the tables?
How would you do one like with the piece?
Oh, yeah. Well, let's do one of those. Good call. Forgot these two looked different. Well, actually, C is very. We can do both of these. So, if you look at this, it says when x equals 1, I get 0. And if x is anything other than 1, I just get what it is. So when x is 1, what am I going to get? 0. Okay, so I know that's a 0. The others, what will I get here?
0.99.
Okay, yeah, I guess this is what I'm pointing at. Yeah, it's just what they are, right? So 0.9, 0.99, 0.999, 1.01, 1. So it's a strange looking equation for our f of x. But as x approaches 1, are the y values approaching the same thing?
Yes.
They are, yeah. They're approaching 1. On the left and the right of 1. Do we care that this is something different? No, that's just like those graphs that had a hole and then had a point up above. Doesn't matter. What's happening on the left and the right side of it? Yeah, they're all going to the same place. What are they going towards? 1 or 0? I heard both. Going towards 1, right? 0.999 is getting really close to 1. 1.001, that's close to 1. It does not matter at all that this is 0. We don't care. All right. And then let's go through this last one. Same thing here. You just have to figure out which piece of your piecewise function you're doing. So when x is 1, does that work in either of our piecewise equations? No, neither of them say when x equals 1, use mean, do they? Okay, so you can say it does not exist or error, whatever you want to say for that. There will not be a value for that. When x is greater than 1, which is all the stuff over here, we use the x squared plus 3 equation. Okay, so if you look at this one says x is greater than 1. This one says x is less than 1. Do either of them say x equals 1? Okay, so we don't have anywhere to put our 1. Okay. With this, you're just plugging these values into this. I'm going to save you a little bit of time. 4.002, 4.02, and then 4.21. What do you think for these over here with the 0.9, 0.99, 0.999? What equation? Yeah, the 2x minus 4, right? I'm plugging them into that. I'm not even gonna do all of them, I'll just do the 0.999. You get negative 2.002. Is that enough to tell you something about the limit? What does it tell you? It does not exist. From the right, it's getting really close to 4. From the left, it's getting really close to negative 2. Those are clearly not going to run into each other, right? So, your notation here, limit of f of x as x approaches 1 does not exist. Okay? So you just have to think about which piece you're plugging into. All right, we're going to do some easier limits now. I don't know if you guys remember from pre-calc last year, this was at the end of the year, when you're doing limits as x approaches a number, your first step should always be just try to plug it in. If you can plug it in and you don't get like an error or dividing by 0, the answer is the limit. Like you just plug it in, that value is it. So can I plug a 2 into this? Yeah. So you're doing 2 squared plus 2 times 2 minus 3. What do I get? 5. Yes, that's your answer. All right, so letter B, what do I do? Can I plug in 7? It works fine, yeah. So I guess 2 C. Plug it in. What do you get? -4. Yeah, don't overthink the easy ones. Okay, what about D? This is the really easy one that everybody always messes up. 6, yes. Remember, this is like the graph of the line y equals 6. No matter what x approaches, what is your y value always going to be? 6. Right. All right, we like those, right? Okay. A little bit of work left to do here. We're not going to fill in the blank up there. We're just going to start. So if I look at A here, can I plug 2 in?
No.
No, what happens?
You gotta see it there.
Yeah, you get 0 in your denominator, which is not okay. So the first thing you should try to do is factor. Now you need to be careful with your notation. It's still going to be the limit as x approaches 2. And then just write it factored. X minus 2, x plus 2 over x minus 2. Okay. All right, so what cancels out now? Yep, that's gone. So then, from there, you can just plug in the 2. So that's just going to equal 2 plus 2, which is 4. Well, you can do that, right? You guys can still factor. Yes. All right. Okay, B is down below, so you guys try that one. Actually, you guys go ahead and try B, C, and D. We'll save the conjugates, though, to do together. All right, guys, let's go through them. So letter B down here. So the limit as x approaches -3. What does that numerator factor into? Not everybody at once. Okay. And then x minus 2. So what cancels? X plus 3. Then we can just plug in our -3, and what do we get? -5. Letter C. Limit as x approaches 3. X minus 3 over, what does this factor into? X minus 3's are gone. So what do you get when you plug in your 3? Good, 1/7. Don't forget the 1 stays at the numerator. Okay. All right, the last one was the trickiest, factoring. Okay. It says x approaches 2/3. Your numerator is 3x minus 2. Again, denominator, I don't care if you guess and check. I don't care if you use grouping. Whatever, as long as you get to the final part, which is 3x minus 2 times what? X minus 1. Okay? Your 3x minus 2's cancel. So, when you plug in 2/3, what do you get? We struggle with that. Is that the hardest part? 1/2/3 minus 1. So that's 1/(-1/3). What does that actually equal? -3, yeah. Yep. Okay, questions on those? The only ones we have left are conjugates now, but was it just the factoring? Or was it plugging in 2/3? We need a reminder on the factoring. Okay. This gets written a million different ways by your Algebra 2 teachers, so I do it this way. You have to think about what multiplies to give you 6 and adds up to -5. So what two numbers multiply to give you a positive 6 and add up to -5? -3, 2, -3 plus -2, okay. What you do over here, leave the 3x squared alone, and then leave the plus 2 alone. We are going to rewrite this -5x using these two numbers. So you're going to write minus 3x minus 2x. So you just split that guy up so you have 4 terms. Okay? Then it's called grouping because you then group. Make sure you get a plus sign between there. Out of the first group, we can take a 3x. See, you get x minus 1 left. Okay? Second group, we want to take a -2 out of there so that we have x minus 1 left because these have to match. Yeah? Okay. That is one of your factors, x minus 1. Then these leftovers create your other factors. Okay? Coming back to you? Yeah? All right. Okay. Maybe. Okay, so let's do these conjugates, the last ones. First, do you remember what it means? What a conjugate is? Multiply and FOIL, okay. By what? Like what? There's usually a square root or something involved. Sometimes an imaginary number, but what happens to the sign in the middle? It's the opposite. So what we would multiply by here you would do times the square root of x plus 1 plus 1 over the square root of x plus 1 plus 1. So it is that sign in the middle there. It's this guy that you will then have the opposite over here. Okay, we're not going to multiply everything out though, because we want some things to go away. So what we're going to do, we'll do the limit as x approaches 0. Let's think about multiplying out our numerator. So what is square root of x plus 1 times square root of x plus 1? X plus 1, okay. Then, the whole reason you picked this was so you'd have a positive square root of x plus 1 and then a negative square root of x plus 1, because what will happen with those? Everything's gone. If they're still there, you screwed up, go back and try again, okay? They should not still be there. Then, the last step, negative 1 times 1 is minus 1. In our denominator, we are going to leave this thing alone. We're just going to say x times square root of x plus 1 plus 1. Don't do anything with that, just leave it alone. Alright, so limit as x approaches 0. What is left in your numerator? What is x plus 1 minus 1? Just x, right? Okay. So we have x over x times square root of x plus 1 plus 1. You're going to see how those x's can go away? That's going to happen every time. Okay. So we have a 1 left in the numerator. And now can I plug my 0 in? Yeah, it's just 1 over square root of 0 plus 1 plus 1. So square root of 0 plus 1, that's the square root of 1, which is 1. And 1 plus 1 is 2. All right, we can add. So the answer to that limit question is 1/2. Okay. Let's do the other one together too, just to make sure we're okay. All right, but you guys tell me, what am I multiplying by?
Root x minus 1 plus 2.
Yes. Over root x plus 1 plus 2. Okay, everybody gets that step, right? Okay, do you guys see how this time it's the numerator that I'm not going to completely multiply out? I'm going to leave that alone, factor, denominator I am going to multiply out. So I've got the limit as x approaches 3. Leave it factored here, x minus 3 times this whole big thing, root x plus 1 plus 2, over. Let's multiply out the denominator. So what is root x plus 1 times root x plus 1?
X plus 1.
X plus 1. And then the whole point of the conjugate, you get 2 root x plus 1 and negative 2 root x plus 1, they're gone. And then minus 4. So, limit as x approaches 3, leave your numerator alone, x minus 3, x plus 1 plus 2. What do you have left in the denominator?
Or x
Well,
minus 3.
yeah, x minus 3, which is convenient, right?
Yeah.
Yeah.
So cancel out.
They're gone then. Then you are just plugging in your 3, so you've got the square root of 3 plus 1. 2. What do we get?
4.
4. Alright, did I lose anybody anywhere along the way? You guys kind of remember this from last year? A little bit? Okay. Some remember me. Alright, that is the end of your notes. Let me do your homework. All right, guys, due next time, sort of due next time, is lesson